Hello, and welcome to Sleepy Ocean. I'm really glad you're here tonight. If you're someone who finds it easier to let go of the day when your mind has somewhere quiet and interesting to travel, somewhere genuinely far from everything, then tonight is going to suit you very well. You can let your shoulders drop, let your breathing slow a little, and let your thoughts drift out ahead of you like something released into calm water. Tonight, we're going to spend time in a place that almost no human being has ever seen, and yet it covers more of this planet than all the land on Earth combined. It's called the Midnight Zone, the deep layer of the ocean where sunlight has never once reached, where the water stays just above freezing and the pressure would flatten anything not built for it, and where life, somehow, has been quietly going on for hundreds of millions of years. We'll visit fish that carry their own light. We'll think about snow that falls through the dark for 2 weeks before it lands. And we'll spend a little time with creatures so patient that some of them have been alive since before certain nations existed. Now, let's begin. The Midnight Zone begins roughly 1,000 meters below the ocean's surface and extends to about 4,000 meters down. That upper boundary, 1,000 meters, is the point where the last trace of sunlight disappears entirely, even on the clearest day above. Above it, in the twilight layer, a faint blue still filters down. Below it, there is nothing. No daily rhythm of light and dark, no seasonal shift, no signal from the sun at all. The zone spans most of the world's ocean floor, an area larger than all the continents placed side by side. It has been dark down there, without interruption, for as long as the oceans have existed. Water in the Midnight Zone stays between 2 and 4 degrees Celsius across nearly its entire depth. That temperature has remained almost unchanged for millions of years. It is not cold in the way a winter morning is cold. It is cold in the way deep time is cold, a steadiness so total it becomes its own kind of stillness. The creatures living here have never experienced warmth. Their enzymes, their muscles, their entire biology is calibrated for a temperature that a human being could not survive in for more than a few minutes. For them, it is simply the world as it has always been. Pressure in the Midnight Zone reaches levels that would collapse a steel vessel not specifically designed to withstand it. At 1,000 meters, the pressure on every surface is roughly 100 times what you feel at sea level. About 100 kilograms pressing on every square centimeter of area. That is the weight of a large adult resting on a surface the size of your thumbnail, and then that same weight stacked 100 times over. Creatures here carry no air spaces inside their bodies. No swim bladders, no lungs, no cavities of any kind. They are dense and continuous, shaped by pressure rather than despite it. Many deep-sea fish produce their own light through a process called bioluminescence. This is not reflected light or borrowed light. It is light made entirely from within, through a chemical reaction between a compound called luciferin and an enzyme that activates it. The result can be a steady glow, a rhythmic pulse, or a sudden flash, depending on the species. Some fish use it to lure prey toward them in the dark. Others use it to recognize members of their own kind. A few use it to cancel out their own silhouette when seen from below, matching faint residual brightness so precisely that they seem to disappear. It has appeared separately in at least 40 different lineages of ocean creatures, one of the most independently evolved traits in the history of life. Around 76% of all deep-sea species are capable of producing light. That is more than 3 in every 4 species living in the midnight zone. Nearly 8 in 10 animals glowing in some way at some point in their lives. It means the darkness down there is not absolute. It flickers, it pulses. It occasionally blazes in brief bursts of cold blue-green fire. If you could sit perfectly still at depth and watch long enough, the dark would occasionally become something else. A slow, quiet light show produced by animals going about their lives, most of which have never been observed by a human being. Marine snow falls continuously through the midnight zone, drifting downward at roughly 1 centimeter per second. Marine snow is not frozen water. It is a constant soft fall of organic particles, dead plankton, shed mucus, bits of shell, the cast-off skins of molting crustaceans. At 1 centimeter per second, a single particle takes nearly 28 hours to travel from the surface to a depth of 1,000 meters. That is more than a full day of falling before it even enters the midnight zone, and then it may drift for days more before it settles. The entire water column is threaded with this slow, continuous descent, invisible from above, falling through the dark like the quietest possible form of weather. Some particles in marine snow take more than 2 weeks to reach the seafloor from the surface. 2 weeks of falling, drifting through layer after layer of dark water, slowing, rising slightly in a current, sinking again, crossing the invisible boundary from twilight into permanent dark, descending past pressure thresholds, through water that has not touched the surface in decades. By the time a particle lands, it may have traveled through a dozen different ecosystems. For the creatures waiting below, it is their entire food supply, a slow rain from a world they will never reach. The anglerfish is among the few animals on Earth where the male and female are biologically fused after mating. The male anglerfish is a tiny creature, in some species no larger than a human thumb. And when he locates a female in the dark, he bites into her skin and holds on. Over weeks, his body begins to merge with hers. His circulatory system connects to hers. His eyes and most of his organs dissolve. Eventually, he exists only as a small, permanently attached partner, nourished entirely by her blood. She may carry several males at once. It is one of the most extreme examples of biological merging between 2 separate animals ever documented. The midnight zone is home to animals with eyes larger in proportion to their body than almost any other creature on Earth. In permanent darkness, even the faintest flash, a distant bioluminescent pulse, a faint shimmer from drifting marine snow, becomes valuable information. Some squid and fish have evolved eyes so large relative to their size that they can detect a single photon of light. The giant squid has eyes that can reach 30 centimeters across, roughly the diameter of a dinner plate, the largest eyes of any animal alive today. They are not searching for sunlight. They are searching for the cold, faint glow of other living things, at distances of many meters, in conditions that would look like pure black to you or me. The midnight zone covers roughly 60% of the Earth's total surface area. 60%. That is more than all the land on every continent combined, more than all the shallow coastal seas, more than the ice caps and the deserts and the forests. It is the single largest habitat on Earth by area and among the least explored. As of recent estimates, human beings have directly observed less than 20% of the ocean floor and a far smaller fraction of the water column above it. The midnight zone remains, in most of its extent, a place that no camera, no instrument, and no human presence has ever reached. Some deep-sea creatures live for more than 200 years. The Greenland shark, which roams the deep cold waters of the North Atlantic and Arctic, has been aged at up to 500 years, making it the longest-lived vertebrate known to science. But even among smaller midnight zone residents, lifespans that would seem extraordinary at the surface are unremarkable here. Low temperature slows metabolism. Low metabolism slows aging. A creature that eats once a week and moves only when necessary can stretch a life across centuries. Some of the animals alive in the midnight zone right now were alive before the Industrial Revolution, before certain nations existed, before particular languages were spoken. The seafloor of the midnight zone is covered in a layer of sediment called abyssal ooze that can be several kilometers thick. This ooze is made almost entirely of the remains of microscopic organisms. The shells of foraminifera, the delicate skeletons of radiolaria, that have been falling to the floor for tens of millions of years. In some places, this layer accumulates at a rate of about 1 centimeter every 1,000 years, a pace so slow it is almost not a pace at all, closer to a geological stillness than to anything that could be called growth. The seafloor has been gathering this quiet record of surface life, layer by silent layer, for longer than our species has existed. Hydrothermal vents in the deep ocean support entire ecosystems that require no sunlight whatsoever. These vents, cracks in the seafloor where superheated water and minerals pour up from below the crust, host communities of tube worms, crabs, shrimp, clams, and bacteria that derive their energy entirely from chemical reactions. They have no relationship with the sun at all. Their food chain begins with bacteria that consume hydrogen sulfide, and everything else builds from there. Discovered only in 1977, these ecosystems have since reshaped our understanding of where life is possible, and have made biologists reconsider what we thought we knew about what life requires. Tube worms at hydrothermal vents can grow to over 2 meters in length with no mouth and no digestive system. 2 meters, roughly the height of a tall adult, grown in an environment with no light and no organic material raining from above. These worms house billions of chemosynthetic bacteria inside a specialized organ, and those bacteria convert chemical energy into nutrition that the worm absorbs directly. The worm is, in a sense, a living container for its own internal food production system, a closed biological loop that has nothing whatsoever to do with the sun, the surface, or the world above the water. The deep ocean holds more dissolved oxygen than most people expect. Cold water holds more dissolved gas than warm water, and the deep ocean is very cold. So, despite being far from the surface where oxygen is produced, the midnight zone carries enough dissolved oxygen for active animal life across most of its depth. This oxygen arrives through thermohaline circulation, dense, cold water from polar regions sinking and traveling along the seafloor for centuries before warming and rising elsewhere. The oxygen surrounding a midnight zone creature right now may have last touched the atmosphere above the North Atlantic several hundred years ago. The global ocean conveyor belt takes roughly 1,000 years to complete a single full circuit. 1,000 years. The time for water to sink at the poles, travel slowly along the seafloor, rise somewhere warmer, and return. The water in the deepest reaches of the midnight zone is what oceanographers call ancient water. Isolated from the surface for so long, it predates written history. A molecule of water at the bottom of the Atlantic today, if you could follow it, would not touch open air again until long after every living person on Earth has been gone. Some deep-sea jellies are almost entirely transparent and nearly invisible, even when directly lit. They carry no hard parts, no pigment, no shell. Just a soft architecture of water and protein, held in shape by a precision that leaves almost no surface for light to catch. In darkness, they are invisible by default. In the beam of a submersible light, they are barely present. A shimmer, a faint outline, the ghost of a bell. Some colonial deep-sea organisms called siphonophores reach lengths of 40 meters, roughly as long as 4 city buses placed end to end, and yet weigh almost nothing and can be nearly impossible to see unless you know exactly what you are looking for. The midnight zone has its own form of weather. Enormous internal waves that move slowly through the water column. These are not surface waves. They form at the invisible boundaries between water layers of different density, deep below anything that ships or storms can reach, and they can tower hundreds of meters from trough to crest, taller than most buildings ever built. They move over periods of hours or days, carrying heat, nutrients, and organisms across vast distances. In some places, they are powerful enough to scour the seafloor, lifting sediment and slowly reshaping the bottom of the ocean the way wind shapes a dune. Just at a pace where months pass like moments. A deep-sea octopus was once observed brooding her eggs continuously for 53 months without eating. 53 months. That is 4.5 years. A female of the species Grenelodon boreopacifica, at a depth of nearly 1,500 meters, was found and refound by remotely operated vehicles attending the same clutch of eggs for the entire duration. She did not leave. She did not eat. She aerated the eggs with her arms and cleaned them and remained. By the time the eggs hatched, she had aged visibly and died not long after. It remains the longest known brooding period of any animal on Earth. The fundamental character of the midnight zone has changed very little in hundreds of millions of years. The darkness is the same darkness. The pressure is the same pressure. The cold is the same cold. While continents drifted, ice ages came and went, and entire kingdoms of surface life rose and disappeared. The deep ocean persisted in a condition of extraordinary stability. Some of the body plans found in midnight zone creatures. The basic shapes they use to move, to feed, to sense, appear in the fossil record from before the age of dinosaurs. Life down there found something that worked a very long time ago and has seen very little reason to change it since. Some deep-sea fish carry their light source permanently inside their skin. Embedded cells called photophores are distributed across their bodies in precise arrangements. Rows along the belly, clusters near the jaw, single points of brightness at the tail. The light is not produced by the fish alone, but by colonies of bioluminescent bacteria that live inside special organs and are maintained there across the fish's entire life. In some species, the arrangement of these photophores is as individual as a fingerprint. No two fish of the same species carry their lights in quite the same pattern. The relationship between fish and bacteria is so old and so embedded that neither can replicate it outside of the other. The fang-toothed fish has the largest teeth of any ocean creature relative to its body size. If a human had teeth scaled to the same proportion, they would be roughly the length of a forearm, and the mouth could not close around them. The fangtooth solves this problem with a pair of deep sockets in the roof of its skull, into which the lower teeth slide when the jaws come together. Despite the appearance, the fangtooth is small, rarely longer than 16 centimeters, roughly the width of an open hand. The name suggests a predator of great size, but it is more like a very determined creature in a very small body, drifting through absolute darkness and waiting. The Midnight Zone contains entire mountain ranges that no human eye has ever seen. The mid-ocean ridge system runs for roughly 65,000 kilometers. That's 1.5 times the circumference of the Earth, beneath the surface of every major ocean, forming the longest continuous mountain chain on the planet. Along its crest, the seafloor is actively splitting apart, pulling in opposite directions at roughly the pace that a fingernail grows. New rock wells up through the gap, cools, and becomes the ocean floor. The mountains themselves have never been touched by light from above, and the tallest among them rival anything that rises above the sea. Sound travels differently in the deep ocean than it does anywhere else. Below a certain depth, pressure and temperature combine to create a layer that traps and channels low-frequency sound with extraordinary efficiency. The so-called sound fixing and ranging channel, or SOFAR channel. A sound introduced into this layer can travel tens of thousands of kilometers before it dissipates, carrying across entire ocean basins without losing coherence. Blue whales are thought to communicate through this channel, their calls crossing distances that a surface vessel would take weeks to sail. The ocean, in this sense, is not silent. It is full of conversations that travel at the speed of sound across half the world. Certain Midnight Zone creatures produce light in colors that only they can see. Most bioluminescence in the deep ocean is blue or blue-green, the wavelengths that travel furthest through water. But at least 2 families of deep-sea fish have evolved the ability to produce red light and to see it while remaining invisible to every other creature around them. Red light does not penetrate far in the deep ocean, so most animals there have no red sensitive cells in their eyes. These fish move through their own private spectrum, illuminating the dark for themselves alone, hunting or navigating in a light that to everyone else simply does not exist. The pressure at the bottom of the Midnight Zone would compress a block of wood to half its original size, at roughly 4,000 meters depth, the lower boundary of the zone. The water above weighs the equivalent of about 400 atmospheres pressing down on every surface. That is 400 times the weight of the air column sitting on your shoulders right now. A sealed metal container dropped to this depth without reinforcement would collapse inward before it reached the floor, the implosion taking less than a second. Creatures that live here carry none of this as burden. Their bodies have no air chambers, no rigid voids for pressure to act upon, and so the weight passes through them as if they are simply part of the water itself. Dragonfish use their own chin light as a lure. A long, slender barbel extends from the lower jaw of many deep-sea dragonfish, tipped at its end with a bioluminescent organ that can be swung, dangled, or held still in the dark. When smaller creatures approach the glow, the dragonfish strikes. The teeth of dragonfish are transparent, made of a material that absorbs light rather than reflecting it, so that no flash of white gives their position away when their mouth opens. The whole system, the lure below, the invisible teeth above, is assembled in a creature that, in most species, is no longer than a pencil. The darkness around it is the environment the entire design relies on. The midnight zone has its own version of rain. Marine snow, which begins in the sunlit water far above, arrives in the deep zone as a transformed material. Not the fresh flakes that left the surface, but something that has been consumed, expelled, and reconsumed many times over during its 2-week descent. By the time it reaches the midnight zone, it tends to arrive in larger aggregates. Clumps and strings of partially digested matter that sink faster than individual particles. Some deep-sea animals have evolved to intercept these aggregates mid-water, hanging in the column like patient nets. Others wait below, on the seafloor, where the material eventually settles into a thin, constant layer of nutrition delivered from a world of sunlight they will never encounter. The giant isopod looks almost exactly like a common woodlouse, except that it can be 50 centimeters long. These crustaceans, relatives of the small gray creatures found under stones in any garden, reach this scale in the cold, pressurized water of the deep ocean, a phenomenon called deep-sea gigantism. The reasons are not fully agreed upon, but slower metabolism, colder temperatures, and the advantage of size in a low-food environment all play a role. Giant isopods have been observed going more than 5 years without eating, entering a metabolic state so reduced that the chemical processes keeping them alive slow to a rate that has no real comparison at the surface. They are patient in a way that patience, as a word, was probably not invented to describe. Hatchetfish are named for the blade-like shape of their bodies. Seen from the side, the silver-flanked hatchetfish is deep and narrow, almost exactly the silhouette of the tool it is named for. Seen from below, however, which is the direction a predator would approach from, it nearly vanishes. Rows of photophores along its belly produce downwelling light that matches the faint glow filtering in from the surface above, a technique called counterillumination. The fish adjusts the brightness of its belly lights in response to changing conditions, brightening when the surface above is lit, dimming when a cloud passes. It is, in a sense, wearing its own camouflage, generated from within rather than painted on. Some midnight zone fish can swallow prey larger than themselves. The black swallower has a stomach with walls so elastic that it can expand to accommodate a fish up to 10 times its own mass. This is not a backup strategy, but the primary one. The swallower's body is built around the idea that meals arrive rarely and must be consumed entirely when found. The jaw unhinges, the stomach distends, and for days afterward, the swallower is visibly distorted by what it contains. The process requires no assistance and no preparation. In a zone where food may pass through only once, the capacity to eat everything at once is worth carrying as permanent equipment. Midnight zone water is extraordinarily still. The surface ocean is in constant motion. Waves, currents, wind-driven mixing. But below about 1,000 meters, the water column becomes almost eerily calm. There are no surface waves at this depth, no wind, and the temperature gradients that drive convection in shallower water have largely equalized. What movement exists is slow and vast. The thermohaline circulation that carries cold water from the poles southward, taking centuries to complete a lap of the globe. Particles settling through this stillness fall in nearly perfect vertical lines, undisturbed by turbulence. The environment resembles, in its physical behavior, something close to an enormous and very cold held breath. Tripod fish stand on the seafloor on 3 elongated fin rays. Two rays extend from the pelvic fins and one from the tail, and the fish props itself above the sediment in a rigid tripod posture, facing into whatever faint current exists in the near-floor water. It holds this position, motionless, oriented, and waits for small crustaceans to be carried toward it by the current. The fin rays can extend to lengths longer than the fish's own body, and they are stiff enough to support the animal's weight against the seafloor without sinking into the soft sediment. The tripod fish is essentially a patient instrument arranged to catch whatever the deep ocean's slow drift delivers. The spookfish has a mirror-based eye unlike any other vertebrate on Earth. Most eyes focus light using a curved lens. The spookfish instead uses a system of tiny crystalline mirrors arranged in a precise geometry that reflects and converges incoming light onto the retina. This design, found in some insects and shrimp, but never before confirmed in a vertebrate, evolved independently in this single deep-sea lineage. The eyes give the fish good sensitivity in very low light without requiring large lenses, which would demand more biological investment than the deep ocean's meager food supply easily supports. The animal solved an optical engineering problem that vertebrate evolution had otherwise never attempted. Some deep-sea shrimp expel bioluminescent fluid as a defense. When startled, certain species of Acanthophyrus shrimp eject a cloud of glowing blue material from their mouth. A burst of light in the darkness that distracts, confuses, or blinds a predator long enough for the shrimp to retreat. The fluid glows for several seconds before fading. This is the deep ocean equivalent of a smokescreen. Not darkness as camouflage, but light as distraction, deployed in an environment where any sudden brightness is as arresting as a flare. The shrimp manufactures the fluid internally, holds it in reserve, and releases it only when the moment requires. The seafloor of the midnight zone is largely unexplored at the level of individual square meters. Despite covering an enormous fraction of Earth's surface, less than 20% of the total ocean floor has been mapped at a resolution fine enough to reveal features smaller than a city block. The midnight zone's portion of that floor, vast, cold, and far below any convenient depth, is among the least visited terrain on the planet. More people have walked on the surface of the moon than have descended to the deepest regions of the midnight zone. The creatures that live there, the structures that form there, and the slow processes unfolding across its floor proceed entirely without witnesses from above. Comb jellies in the deep ocean can produce rapidly shifting waves of color across their bodies. Unlike most deep-sea bioluminescence, which is a chemical reaction, the shimmering display of comb jellies is structural, caused by rows of tiny beating hairs called cilia that diffract ambient light into a moving iridescent band. In the midnight zone, where almost no ambient light exists, this display is rarely visible unless another source of light is present. When it is visible, the bands of color travel from one end of the body to the other in continuous rolling pulses, giving the animal the appearance of something much more complex than it is. Comb jellies have no brain, no centralized nervous system, just a body that shimmers. The midnight zone holds water that has been isolated from the surface for hundreds of years. Because the deep ocean turns over so slowly, the thermohaline conveyor completing one circuit in roughly 1,000 years. Water that has descended into the midnight zone may have last touched the surface during a century that no living person has seen. The oxygen dissolved in that water was drawn in from the atmosphere long ago, in a different era of the world's climate and chemistry. The water itself is, in a meaningful sense, old. carrying a record of the conditions that existed at the surface when it submerged, sealed in place by the cold and the weight of everything above it. Some deep-sea cucumbers process an entire body length of sediment each hour. Sea cucumbers in the midnight zone are among the zone's most effective recyclers of organic material. They ingest the top layer of seafloor sediment, extract what nutrition remains, and expel the processed material behind them in neat coiled strings. A single animal can move slowly across the floor, consuming sediment continuously, and in doing so, turns over a remarkable volume of material across the span of a year. In some regions of the deep seafloor, the surface layer of sediment has passed through a sea cucumber at least once. A form of farming carried out by an animal with no brain, no plan, and no awareness that it is doing anything at all. Vampire squid are neither squid nor octopus, but an order unto themselves. They are the only surviving member of Vampiromorpha, a group that branched off from the lineage leading to modern squid and octopus more than 300 million years ago. They do not hunt. Instead, they drift through the midnight zone, trailing long filaments that collect marine snow. The slowly falling particles of organic matter drifting down from above. When enough material has accumulated on the filaments, they draw them through their arms and consume it. The vampire squid feeds on the dead, not the living, and has sustained this approach long enough to outlast nearly every lineage of creature that shared the ocean with its ancestors. Some deep-sea fish carry their own clocks built entirely from bioluminescence. Certain species in the midnight zone produce rhythmic light pulses that repeat at near-fixed intervals. Patterns so regular that researchers studying them in the 1980s initially suspected instrument error. The pulses are generated not by a single organ, but by a distributed system of photophores spread along the body, flickering in a loose, rolling sequence that travels from tail to snout and back again. No one is entirely certain what function this rhythm serves. It may be a form of species recognition in the dark, a kind of slow-moving signature that another member of the same species can read at a distance of several meters. In a place where no other signal reliably travels, a repeating light becomes something close to a name. The deep ocean contains an acoustic phenomenon known as the biological scattering layer. This is a broad band of organisms. Fish, shrimp, small squid, and gelatinous animals that descend each morning and rise each evening in one of the largest coordinated migrations on the planet. The layer can be several hundred meters thick and stretches across entire ocean basins. During the Second World War, sonar operators tracking submarines began returning puzzling echoes from what appeared to be a false seafloor that moved. It took years to determine that the echo was coming from life, from hundreds of billions of small creatures rising and falling together, their swim bladders and shells reflecting sound upward as cleanly as rock. The migration covers roughly 400 to 500 meters of vertical distance each day. A daily round trip that, for an animal a few centimeters long, is equivalent to a human climbing a mountain and descending it again between dusk and dawn. Certain deep-sea amphipods can survive pressures that would instantly collapse a steel diving bell. Amphipods are small crustaceans, closely related to the creatures you might find under a rock in a tidal pool. Yet some species have been recovered from trenches deeper than 10,000 meters. That's more than 10 kilometers straight down. At those depths, the pressure exceeds 1,000 times the pressure at the surface. The amphipods have no swim bladder, no air-filled chambers, and no rigid shell thick enough to explain their resilience. Instead, Their entire body chemistry has adapted at the molecular level. Their enzymes are shaped differently from those of shallow water relatives, tuned to function under compression that would denature the proteins of almost any other animal. A small creature no longer than your thumb, built for conditions we can barely generate even in a laboratory. The deepest recorded fish sighting belongs to a species of snailfish. In 2023, a snailfish was filmed at 8,336 meters below the surface. That's deep enough to stack nearly 3 Burj Khalifa towers on top of each other and still have room for another half. Snailfish are soft-bodied, translucent, and look almost nothing like what most people picture when they imagine a creature built for the extreme deep. They are gentle-looking animals, with small fins and a tadpole shape, resembling something you might find in a shallow estuary. But their tissues contain a chemical called trimethylamine oxide, TMAO, which acts as a molecular counterweight to pressure, preventing their proteins from folding incorrectly under compression. The deeper the fish lives, the more TMAO its tissues contain, in a near-perfect gradient from the surface to the hadal zone. Many midnight zone creatures replace bone with cartilage or soft tissue to save energy. Bone is metabolically expensive to build and maintain, and in an environment where food arrives only as a slow drizzle of marine snow, the savings matter enormously. Fish that in shallow water would have a rigid skeleton instead carry a framework closer to the consistency of firm gelatin, dense enough to support the body's shape, but light enough to reduce the caloric cost of simply existing. Some species take this further, reducing even their muscle mass to the minimum needed for occasional bursts of motion. The result is a body that in many ways resembles a design refined over hundreds of millions of years for one purpose: to do as close to nothing as possible while remaining alive and ready indefinitely for the next meal. The midnight zone is nearly silent, but it is not completely silent. Low-frequency sound carries enormous distances in the deep ocean, and the zone receives the faint residue of almost every significant sound produced on or near the surface. The grind of tectonic plates shifting, the long bass notes of blue whales traveling thousands of kilometers through the Sofar Channel, the rhythmic pulsing of distant storms agitating the water column far above. None of these sounds arrive with the sharpness they carried at the surface. They arrive as slow, rounded vibrations, softened by distance and absorption, like hearing a piece of music played very quietly through several walls. Many deep-sea animals have sensory organs adapted to detect exactly this kind of diffuse, low-frequency input. Not hearing in the way we hear, but feeling the ocean's distant conversations through the tissue of their own bodies. The barrel-eye fish has a transparent head. This is not a metaphor or a simplification. The dome of the barrel-eye skull is composed of a clear, flexible, fluid-filled tissue that allows the animal's tubular eyes to rotate freely inside it. The eyes themselves point upward by default, scanning the faint silhouettes of prey against the dim light filtering down from above. When the fish moves to feed, the eyes can rotate forward, giving it binocular vision directly ahead. For decades, specimens brought to the surface were assumed to have fixed, forward-facing eyes because the transparent dome collapses when removed from pressure, and what remained looked like a conventional face. It was only when the animal was filmed alive and intact at depth that the true structure became clear. A creature that sees the world through its own forehead, scanning the sky of its ocean from somewhere far below. Deep-sea fish livers can account for a third of the animal's total body weight. In shallow water fish, the liver is a modest organ. Important, but not dominant. In many midnight zone species, it has expanded into a vast lipid storage structure, filling the body cavity and providing both buoyancy and a long-term energy reserve. The lipids stored there are not the same as those found in surface animals. They are specialized wax esters, compounds that are nearly indigestible by most predators and that remain liquid at near freezing temperatures, unlike the fats that would solidify and become useless in the cold. The liver is, in effect, the animal's fuel tank, its ballast system, and its slow burn engine all in one organ. A solution so effective that it evolved independently in multiple unrelated deep-sea lineages, arriving at the same answer from different starting points. The deep ocean floor holds mountains that have never cast a shadow, seamounts. Submarine volcanoes that rise from the seafloor but do not break the surface, number in the tens of thousands across the world's ocean basins. Many of them are taller than anything on the continents above sea level, yet because no light reaches them, they stand in complete and permanent darkness, unknown to the surface world entirely. Some seamounts top out at 3 or 4 kilometers in height, taller than most of the European Alps. While remaining entirely submerged, their peaks still a kilometer or more below the waves. The communities of life that develop on their flanks and summits are often unique to that single mountain, isolated by the surrounding depths the way a peak above the tree line is isolated from the valleys on either side. Glass sponges build reefs that have been growing for 9,000 years. These are not coral reefs. Glass sponges belong to a completely different branch of life. Their skeletons made of silica rather than calcium carbonate. They grow primarily in cold, deep water along continental margins, extending down well into the midnight zone in some locations. Individual sponges grow slowly, adding only a centimeter or two per year. But over millennia, the accumulated structure of dead sponge skeletons and living tissue can rise to several meters in height and stretch for kilometers along the seafloor. The reefs function as complex habitat. Their latticed silica frameworks shelter rockfish, crabs, shrimp, and dozens of invertebrate species that would otherwise have nowhere to anchor in the soft sediment below. A structure built over 9,000 years at a rate too slow to observe, sheltering animals that have no concept of the history beneath them. Some animals in the midnight zone reproduce so rarely that a single individual may spawn only once in its entire life. In environments where energy is scarce and the body must ration everything it does, reproduction becomes an event rather than a routine. Certain deep-sea fish do not reach sexual maturity until they are several decades old. Others produce only a small number of eggs, sometimes fewer than a dozen, in a single lifetime, and invest heavily in each one. This is the opposite strategy from most surface fish, which spawn in the millions and rely on sheer numbers for any offspring to survive. In the deep, where conditions are stable and predation pressure follows entirely different rules, a small investment, made late, once, may be sufficient. The ocean floor holds animals going about their lives on timescales that feel less like biology and more like geology. The water in the deepest parts of the midnight zone is among the clearest on Earth. Clarity in ocean water depends on the absence of particles, plankton, suspended sediment, organic material. And in the deep ocean, far from river inputs and far below the productive surface layers, almost none of these are present. Light, if it could somehow reach those depths, would travel through the water with almost no scattering. Researchers studying deep water optics have found that light attenuation in the clearest abyssal water is close to the theoretical minimum for pure seawater. This means that the darkness of the midnight zone is not murkiness. It is not the dark of fog or silt. It is the dark of perfect transparency with no source of illumination. A darkness so complete it is, in a sense, flawless. Some deep-sea animals navigate using the Earth's magnetic field. The deep ocean offers no landmarks, no light gradients, and few chemical cues reliable enough to use for orientation across large distances. Yet certain species, including some deep-diving fish and squid, appear to detect and respond to the subtle variations in the planet's magnetic field, using it as an invisible map of the seafloor below them and the ocean around them. The mechanism is not fully understood. In some animals, researchers have found tiny crystals of magnetite, the same mineral used in a compass, embedded in tissue near the brain. These crystals align with magnetic field lines and may allow the animal to sense not just direction, but the specific intensity of the field at a given location, which varies in predictable ways across the ocean floor. They navigate through total darkness using a sense we have no direct analog for. The midnight zone receives less than 1% of the organic carbon that falls from the surface. Marine snow begins its descent from the sunlit upper ocean and is intercepted, consumed, broken down, and reconstituted at nearly every depth before it reaches the deep. By the time particles reach 1,000 meters, the majority of the original carbon content has already been metabolized by bacteria and small animals in the water column above. What arrives at 2, 3, or 4,000 meters is the residue of a residue. The fraction that was too dense, too large, or too chemically resistant to be processed on the way down. Yet this fraction sustains an entire world. The community of life on and just above the abyssal seafloor has evolved over hundreds of millions of years to extract the maximum possible energy from what, by any surface standard, would be considered almost nothing at all. Certain bioluminescent flashes in the midnight zone are visible from remotely operated vehicles more than 20 meters away. In absolute darkness, even a small amount of light carries an enormous distance, far more than it would in the scattering haze of a surface environment. Researchers aboard deep submersibles have occasionally turned off all external lights and allowed their eyes, or their cameras, to adjust to the ambient dark, and what they record is not a void, but a field of intermittent, unpredictable light. Flashes of blue-green, pale yellow, and in rare cases red appear and disappear across the field of view, some lasting a fraction of a second, others holding for several seconds in slow, pulsing sequences. The effect has been described by multiple researchers as looking at a city seen from an aircraft on a partly cloudy night. Not dense, not continuous, but present in every direction at once. The deep ocean has its own version of soil. On the continental shelves and in the upper reaches of the abyssal plain, the seafloor is covered in sediment that has accumulated over millions of years, compressed by its own weight into a layered record of everything that has happened above it. Different layers carry different chemistry. The ratio of oxygen isotopes changes with ancient temperature. The presence of specific microfossils marks specific geological periods. The thickness of individual layers records the productivity of the surface ocean at that time. Drilling into the deep sea sediment is, in effect, reading backwards through time. A core pulled from the seafloor can contain information stretching back tens of millions of years in a column no longer than a human arm. The deep ocean keeps a record that the continents, with their erosion and upheaval, cannot. Some midnight zone jellyfish are older as a lineage than the dinosaurs. True jellyfish. the Medusozoa, appear in the fossil record more than 500 million years ago, which places them before the first trees, before the first land vertebrates, and roughly 300 million years before the first dinosaurs walked on a continent that did not yet look like any we would recognize. The body plan that persists in the deep ocean today. A bell, trailing tentacles, no hard parts, is essentially the same body plan preserved in Cambrian fossils from the ancient seafloor. This is not because jellyfish stopped evolving. It is because a body built from soft tissue, propelled by gentle pulsing, requiring no skeleton and very little oxygen, is an answer that works across an enormous range of conditions. The deep ocean is full of ancient answers. The salinity of midnight zone water is nearly identical across all of Earth's ocean basins. At depth, the great surface differences between ocean regions, the slightly fresher Arctic, the saltier Mediterranean outflow, the diluted zones near river mouths, are smoothed away by the slow mixing of the global conveyor. Deep water that formed in the North Atlantic carries its signature salinity into the Indian Ocean and the Pacific over the course of centuries. And what arrives is not dramatically different from what left. Researchers measuring deep water salinity across the globe find values clustered within a very narrow range, roughly 34.5 to 35 parts per thousand. A consistency that reflects not the absence of variation, but the thoroughness with which the ocean eventually averages everything out. The deep is where the ocean becomes, in a sense, itself. Some deep-sea fish produce sounds by vibrating their swim bladders. This is not rare in fish generally. Many shallow water species use the same mechanism to produce grunts, knocks, and low thrumming tones for communication. But in the midnight zone, where bioluminescence already serves as one channel of information, sound offers a second channel that works at different ranges and through different media. Low-frequency vibrations generated by a swim bladder travel efficiently through the dense cold water of the deep, carrying farther than light and requiring no alignment between sender and receiver. Some of the sounds produced are below the threshold of human hearing. Infrasound, felt as pressure rather than tone. Whether these sounds are used for mate location, territory signaling, or some function not yet identified remains an active area of research, but the fish are not silent, and the ocean is listening. The midnight zone holds conditions that have remained largely unchanged since before the first humans walked the Earth. The temperature at 3,000 meters has varied by perhaps 1 or 2 degrees Celsius across the entire span of human existence. Across the ice ages, the warm interglacials, the rise and fall of every civilization, the pressure has not changed. The chemistry has shifted only slightly with the slow cycling of the global conveyor. For the animals that live there, adapted over millions of years to a stable world, this continuity is not simply comfortable. It is the condition their entire biology was built around. They exist in a place that has not asked them to change, and so they have not, and the deep ocean carries within it an extraordinary stillness. Not the stillness of absence, but the stillness of something that has simply never had reason to hurry. Some deep-sea fish carry their own light source forward like a lantern on a stem. The anglerfish is the most recognized example, but dozens of unrelated lineages have arrived at the same solution independently. A thin appendage tipped with a bioluminescent organ dangled in front of the mouth. The light is not produced by the fish itself, but by colonies of bacteria living inside the lure, fed and housed in exchange for their glow. In some species, the lure pulses slowly. In others, it holds a steady dim blue. Prey drawn toward it from the surrounding dark have no way of knowing that the source of the light is also the source of the danger. The deep ocean contains mountain ranges that have never been mapped in detail. The mid-ocean ridge system is known as the longest continuous geological feature on Earth, stretching some 65,000 kilometers through every ocean basin. But vast sections of it have been seen by human instruments only in coarse outlines. The peaks and valleys of these ranges rival anything on the continents in sheer physical scale. Seamounts rising 3 and 4 kilometers from the seafloor remain largely uncharted, somewhere below you as you rest. Those mountains are sitting in complete and undisturbed silence, as they have for tens of millions of years. The midnight zone is home to a creature that reproduces by dissolving into its surroundings. The salp is a barrel-shaped, transparent animal that feeds by filtering seawater through its body as it pulses forward. In warm seasons, a single salp can clone itself into chains of hundreds of identical individuals, each linked to the next, propelling the whole colony through the water column in slow spiraling sweeps. When conditions shift, the chain breaks apart, and each individual is capable of producing a sexually reproducing offspring on its own. A single salp can cycle between these two entirely different modes of reproduction, colonial and individual, within a single lifetime. Pressure in the deep ocean does not crush. It compresses. The distinction matters. Crushing implies collapse. Compression implies that every molecule of a structure is pushed slightly closer to its neighbors. For animals that contain no air, compression changes almost nothing about their internal architecture. A fish living at 3,000 meters carries water-filled tissue at essentially the same density as the surrounding ocean. It is, in a sense, already made of the pressure it lives in. This is why deep-sea creatures brought rapidly to the surface suffer damage not from the depth they came from, but from the sudden removal of the pressure that held their cells in their correct configuration. Certain deep-sea worms build tubes out of their own silk and sediment. These structures, sometimes called polycate tubes, are anchored to the seafloor and extend upward into the water column, where the worm feeds by extending a fan of fine filaments into any passing current. The tubes are constructed grain by grain, each particle selected and cemented with mucus secreted by the worm's own body. Some tubes have been found with walls composed of sediment particles sorted by size, coarser on the outside, finer within, suggesting a degree of material selection that took place without eyes, without hands, and in total darkness. Sound travels through the deep ocean without losing its shape over very long distances. In the midnight zone, the physical properties of water, its temperature, its salinity, its density, create a channel that bends sound waves back toward a central layer, rather than letting them scatter upward or downward. This layer, called the SOFAR channel, acts like a corridor along which low-frequency sound can travel for thousands of kilometers with almost no loss of energy. A signal introduced into it at one point in the ocean can, under the right conditions, be detected on the far side of a basin. Whales have used this corridor for communication for millions of years longer than we have known it existed. Some midnight zone fish have a kind of invisible armor. The loose-jawed dragonfish, along with a small number of related species, produces and detects red light, a wavelength that most deep-sea creatures cannot see at all. Red light is absorbed quickly in water and vanishes within the first few hundred meters. So by the time any organism reaches the midnight zone, evolution has typically abandoned the machinery needed to detect it. The dragonfish, however, has retained, or re-evolved, red sensitive pigments in its eyes, giving it a visual channel invisible to its prey. It can illuminate a target directly while remaining, from the prey's perspective, in complete darkness. The floor of the midnight zone shifts slowly beneath its own weight. Sediment accumulating over millions of years does not simply pile up indefinitely. The deepest layers are compressed by the material above them, gradually consolidating into a denser and denser substrate. At the very bottom of the sediment column, material deposited tens of millions of years ago has been compacted into something approaching soft rock. Above it, layer by layer, each stratum is slightly younger and slightly less dense. A drill core pulled from the seafloor is, in effect, a timeline. The top slice dated to this decade, the deepest slice to an era before the continents were in their current positions. The lanternfish is one of the most numerous vertebrates on Earth. It is also one of the least observed. Measuring between 2 and 15 centimeters in length, lanternfish spend their days in the midnight zone and rise toward the surface each night in one of the largest coordinated animal movements on the planet. Billions of them ascend together, feed in the surface waters under cover of darkness, and then descend again before morning. The columns they travel, hundreds of meters of open water, navigated twice every day, are too large to picture and too routine to register as remarkable. Their combined mass has been estimated to exceed the total weight of all the world's human-made structures. The deep ocean contains a layer of water that formed at the surface during a different era, thermohaline circulation. The slow, global movement driven by differences in temperature and salt concentration carries surface water downward in a few specific regions near the poles, where it cools and sinks. This water then spreads slowly across the ocean floor, traveling for centuries before mixing back toward the surface. The water resting beneath you in the midnight zone right now may have last touched open air during a period when the world above it looked substantially different from the world it will eventually return to. Certain deep-sea animals navigate by touch. In the permanent darkness of the midnight zone, many species have elongated sensory filaments, extensions of fin rays, antennae, or specialized skin tissue that detect pressure waves, chemical gradients, and the minute electrical fields generated by nearby living things. The lateral line system, which detects water displacement in most fish, becomes especially sensitive in deep-sea species, where it can register the passage of another creature several body lengths away. Some tripod fish extend their pelvic fins into the water as they stand motionless on the seafloor, using them not for movement, but as a forward-facing sensory array. The midnight zone contains animals that age so slowly they appear to have no age at all. The ocean quahog clam, which lives at depth across the North Atlantic, has been found with growth rings in its shell corresponding to over 500 years of continuous life. Individual specimens have been measured at ages exceeding 507 years, making them among the oldest animals with confirmed lifespans ever documented. At those depths, metabolism slows, predation pressure is low, and the stability of the environment removes many of the stressors that accelerate aging in shallow water species. These animals began their lives in a world that bore almost no resemblance to the one their shells would eventually be collected from. Deep-sea fish often produce sounds that travel well beyond the range of their neighbors. The swim bladder, a gas-filled organ used primarily for buoyancy, doubles in many species as a resonating chamber. By contracting and releasing muscles around it at precise intervals, these fish generate low-frequency pulses that carry through the water column with relatively little attenuation. In the midnight zone, where visual communication is limited by the range of any bioluminescent signal, sound provides a second channel, one that can reach across hundreds of meters of open water without producing any visible signature. The deep ocean, despite its silence to human ears, carries a continuous low murmur of biological origin. Certain deep-sea sponges are older than any tree currently standing on land. Glass sponges, named for their silica skeletons, which form intricate lattice structures resembling spun glass, grow at rates of a few millimeters per year and have been found alive in reefs that began forming well before the last ice age. Their skeletons, once the living tissue is gone, persist on the seafloor for thousands of years, sheltering complex communities of small animals inside the geometric chambers of their remains. A single glass sponge reef can support hundreds of associated species. Shrimp, fish, worms, mollusks, all organized around a structure that the sponge itself built without a brain, without a nervous system, and without any awareness of the community forming within it. The scales of a deep-sea fish are sometimes thinner than a human fingernail. In shallow water, scales serve multiple functions: defense, hydrodynamic efficiency, coloration, structural support. In the midnight zone, where predators approach from any direction without warning, and where speed is less useful than stillness, scales become energetically costly to maintain. Many deep-sea species have reduced their scales to translucent membranes or abandoned them entirely, leaving skin that is soft, dark, and nearly featureless. The metabolic savings are small on any given day, but across a life, measured in decades or centuries, every saved calorie represents a margin of survival. The deep ocean floor receives occasional visitors from above that carry no organic material at all. Pumice, the porous volcanic rock light enough to float, travels across ocean surfaces for years after major eruptions, gradually becoming waterlogged, and sinks slowly into the deep. On the seafloor, it comes to rest among sediments entirely unlike itself, a pale, rough fragment among fine-grained ooze, far from any volcanic source. Some deep-sea sediment cores contain pumice layers that have been traced to specific eruptions thousands of kilometers away. The rock sat on the surface for months or years, and then descended through the entire water column to land in the midnight zone. A record of a distant event, preserved in silence. Bioluminescence in the deep ocean can function as a form of alarm. The ostracode, a small crustacean found throughout the midnight zone, produces a brilliant blue flash when threatened. Not to illuminate anything, but to make itself conspicuous enough that the predator eating it becomes conspicuous in turn. Any larger animal glowing from a recent meal becomes visible to its own predators, creating a chain of risk that travels upward through the food web. This secondary deterrence, sometimes called burglar alarm bioluminescence, effectively recruits the whole ecosystem into the defense of a single small animal. The flash lasts less than a second, but the consequence of producing it can extend much further. The water column of the midnight zone acts as a slow-motion archive. Every particle that sinks through it, a fragment of shell, a drifting spore, a grain of mineral carried off a continent by wind, passes through an environment so stable that its descent can take weeks. As it falls, it carries chemical information about the conditions at the surface where it formed: isotope ratios, trace metals, the preserved remnants of organic compounds. Scientists reading sediment cores can detect past climates not just in the layers themselves, but in the composition of individual particles within them. The midnight zone collects what falls into it without preference, and in doing so, it holds a record of the world above that nothing on the surface has managed to preserve so completely. Certain deep-sea shrimp detect light with organs that are not eyes, along the back of species such as Remicaris exoculata, found near hydrothermal vents. There are patches of light-sensitive tissue with no lens, no focusing structure, and no equivalent in any shallow water relative. These patches appear to respond to the faint, diffuse glow emitted by superheated vent water. A glow so dim, it is invisible to any instrument except the most sensitive scientific detectors. The shrimp use this signal not to see in any conventional sense, but to orient themselves relative to the vent, staying close enough to feed, but not so close that the temperature becomes lethal. They navigate by a light that no other animal has evolved to notice. The midnight zone produces weather of its own kind, not storms in any surface sense, but slow, vast movements of cold water driven by differences in density. Bottom currents that travel along the seafloor for thousands of kilometers, eroding sediment and depositing it in long, smooth drifts. These currents have carved channels in the abyssal plain as clearly defined as rivers, flowing at speeds far too slow to feel but fast enough over geological time to reshape the floor they cross. Where two such currents meet, the sediment record is disturbed and mixed. Layers that accumulated in sequence are folded and overturned. The deep ocean, in its stillness, is not entirely still. Some deep-sea fish grow teeth on the inside of their skulls. In a handful of species that hunt in the midnight zone, the teeth do not simply line the jaw. They curve inward, angling back toward the throat in overlapping rows that press deeper when prey pushes against them. A creature trying to escape such a mouth finds that each movement drives the teeth further in. The system requires no muscular effort from the fish. It is entirely passive, a geometry of capture rather than a mechanism of force. In these fish, the mouth functions less like a jaw and more like a slow and patient arrangement of angles. The deep ocean does not waste energy on what can be made effortless. There are fish in the midnight zone whose skeletons have almost entirely dissolved. In the permanent cold below 1,000 meters, some species have reduced the rigid calcium structures of the skeleton to near nothing, replacing them with cartilage, soft tissue, and flexible membranes. The result is a body that weighs almost nothing in water, neutrally buoyant without a swim bladder, requiring almost no muscular effort to maintain depth. These fish drift more than they swim. Some are nearly transparent, their organs visible as faint shadows through skin that feels, to the touch, like very cold water held loosely in a membrane. The deep ocean has a way of making things lighter than they appear. Some midnight zone creatures navigate entirely by vibration. The lateral line, a sensory organ running along the flanks of most fish, detects tiny pressure changes in the water around it, the kind produced by another body moving nearby, a current deflected around a rock, or the slow displacement of water by a tailstroke 30 meters ahead. In the midnight zone, where light is absent, this system becomes the primary way of reading the world. Some deep-sea fish have lateral lines so sensitive they can detect the pressure wave of a small creature stirring the water at several body lengths distance. The fish does not see its surroundings so much as feel them. assembling a picture of space from disturbance alone. The deep ocean contains vast rivers that no surface storm has ever touched. Below the turbulent upper layer of the ocean, water moves in slow, broad flows driven not by wind, but by differences in temperature and salt content. Currents kilometers wide, invisible from above, carrying enormous volumes of water from one basin to another over centuries. A parcel of water that enters the deep Atlantic near Greenland may travel southward through the interior for 400 years before rising again in the Pacific. These flows have no banks and no names in the way surface rivers do. They move with a patience that belongs to geology, not to weather. Some deep-sea animals have no fixed front end and no fixed back end. Sea cucumbers in the midnight zone feed by drawing sediment in at one end and passing it through at the other. But several species can reverse this direction entirely. If conditions shift, or if a disturbance arrives, they redirect their internal flow and begin processing material from what was previously the exit. There is no permanent head, no permanent tail. The animal moves whichever way is currently profitable without preference. At this depth, where food arrives in quantities so small that nothing can be rejected, the body has become fully reversible. A soft tube that takes what comes and works with complete patience in either direction. The coldest and densest water in the ocean forms at the surface before sinking to the very bottom. Near Antarctica, in winter, sea ice forming at the surface pushes salt out of the freezing water and into the layer just below. That layer becomes so dense, it sinks immediately, all the way to the seafloor, spreading outward across the bottom of every ocean basin in a slow, cold flood that takes centuries to complete. The water sitting at the very bottom of the midnight zone right now was last at the surface during a winter that predates any living memory. It sank, and it has been traveling the interior of the ocean ever since. Cold, dense, and carrying the chemistry of a world that no longer exists above. Some colonial deep-sea animals pass bioluminescent signals along their entire length. Siphonophores, organisms composed of hundreds of specialized individual bodies working as a single animal, can produce pulses of light that travel from one end of the colony to the other in a rippling wave. Some colonies reach 40 meters in length, roughly the height of a 12-story building. And a single signal can travel that entire distance in under a second. The function may be a coordinated startle response or a form of internal communication between sections of the colony. Each flash involves hundreds of separate light-producing cells firing in sequence. Seen from a submersible's camera, it resembles a slow, cold fire moving through a living thread. Midnight zone water has not been touched by wind in centuries. From the moment deep water sinks below the surface mixing layer, roughly 200 meters down, it enters a world where wind has no reach. Surface storms that drive 12-meter swells, hurricanes that churn the upper ocean for days. None of these events penetrate to the midnight zone. The deep water moves according to its own interior logic, driven by density rather than momentum, shaped by the geometry of ocean basins rather than by weather. A parcel of water traveling the interior of the Pacific may spend 500 years in the deep ocean without once feeling the pressure of wind. Above, the surface rearranges itself constantly. Below, nothing changes but the slow drift of chemistry. Some deep-sea fish produce sound to locate one another across hundreds of meters of dark water. Certain species in the midnight zone generate low-frequency pulses by rapidly contracting muscles attached to the swim bladder, a gas-filled organ that vibrates like a struck drum when squeezed. Sound travels through water roughly 4.5 times faster than through air, and at the low frequencies these fish produce, a signal can propagate hundreds of meters through the water column before fading. The pulses are species-specific. Different rhythms, different intervals, different carrier tones, functioning as identification signals in a world where visual recognition is impossible. Two fish of the same species, separated by a distance at which they could never see each other, can still find one another by rhythm alone. The deepest sea cucumber ever filmed was recorded at more than 10,000 meters. In the Mariana Trench, where pressure reaches over 1,000 atmospheres, equivalent to the weight of roughly 1,000 kilograms pressing on every square centimeter. Sea cucumbers have been filmed moving across the sediment at the very bottom, feeding and processing mud at their usual unhurried pace. The species found at these depths are pale and nearly translucent, their bodies adapted to pressures that would collapse most rigid structures instantly. They appear to make up a significant portion of the animal biomass at the deepest point on Earth. At a depth where almost nothing else survives, a soft-bodied animal that eats sediment and carries no defenses is among the most successful creatures alive. Some deep-sea fish have eyes that are permanently aimed upward. In a number of midnight zone species, the barrel eye among the most studied, the eyes point directly overhead rather than forward or to the sides. This arrangement sacrifices nearly all lateral vision in exchange for a continuous view of the water column above. In the midnight zone, the faint glow of the near-surface layer, the silhouette of a creature passing above, the shadow of a descending piece of marine snow. These are the most reliable sources of visual information available. By looking permanently upward, the fish trades the world around it for the world above. In permanent darkness, the world above is the only world that still holds light. Deep-sea sediment contains a layered record stretching back tens of millions of years. At the bottom of the deep ocean, sediment accumulates at roughly 1 centimeter every 1,000 years. A core drilled to a depth of 10 meters contains approximately 10 million years of compressed history, each thin layer holding chemical signatures of the water present when it settled, ratios of oxygen isotopes that shift with ocean temperature, concentrations of trace metals that record ancient current patterns, the shells of microscopic organisms whose species changed as ocean chemistry evolved. Scientists read these cores the way a reader moves through a book. Each centimeter a new chapter, each layer a record of conditions that no instrument was present to measure. The Midnight Zone has been keeping its own archive since before our genus existed. Pressure in the Midnight Zone has reshaped the chemistry of life at the molecular level. At depth, the weight of the water column above compresses everything it touches, including the chemical reactions inside living cells. Enzymes, the proteins that drive metabolism, become less flexible under high pressure, their active sites deforming slightly and reducing their efficiency. Deep-sea organisms have solved this by evolving enzymes with slightly different molecular geometries that remain flexible under compression. The same chemical reaction that powers a surface fish's muscles runs in a deep-sea fish's muscles through a structurally different version of the same protein, tuned to pressure the way a surface enzyme is tuned to warmth. Life at this depth has not simply moved to a harsher place. It has been rebuilt, molecule by molecule, to belong there. Some deep-sea animals shed entire limbs as a form of escape. Several species of brittle star, a relative of the sea star, common across the midnight zone, can voluntarily detach one or more of their arms if seized by a predator. The arm continues to move after separation, writhing and drawing attention, while the main body withdraws into the sediment. The lost arm regrows over the following weeks, produced from stored nutrients at a cost far smaller than what the animal would lose if taken entire. The detachment happens in a fraction of a second, at a predetermined fracture point near the base of the limb. Escape in the deep ocean sometimes looks less like fleeing and more like leaving a part of yourself behind. The Midnight Zone contains mountain ranges no human eye has ever seen. Seamounts, underwater mountains formed by volcanic activity, number in the tens of thousands across the ocean floor, and the great majority remain unvisited by any instrument. Many rise 2,000 meters or more from the surrounding seafloor, comparable in height to the tallest peaks of the European Alps. Yet their summits remain far below the reach of sunlight. The slopes of a seamount concentrate current flow and create conditions where animal communities can be far richer than those of the surrounding abyssal plain. Some of these mountains are older than the Atlantic Ocean itself. They have been standing in the dark for longer than any surface range we have ever given a name. Dust from distant deserts eventually settles into the Midnight Zone. Fine particles blown from the Sahara, the Gobi, and the Australian interior cross ocean basins in the upper atmosphere before settling at the surface and beginning the long descent through the water column. By the time this dust reaches the Midnight Zone, it has been incorporated into marine snow, ingested by mid-water organisms, repackaged into fecal pellets, and intercepted by layer after layer of the biological community above. Animals at the seafloor have been found carrying mineral particles in their tissues that originated thousands of kilometers away on a dry land surface. The Midnight Zone receives material from every continent, carried not by rivers, but by wind and time and the slow weight of water. Some deep-sea fish have lost their stomachs entirely. In a small number of Midnight Zone species, the stomach has been eliminated over evolutionary time, replaced by a simple tube connecting mouth to intestine. These fish cannot store food between meals. Everything consumed passes directly through. The evolutionary logic appears to be metabolic reduction. A stomach requires energy to maintain even when empty, and in an environment where meals arrive rarely and unpredictably, the cost of maintaining one may exceed its benefit. The fish feeds when it can, extracts what nutrition passes through, and continues. It is one of the more extreme examples of the deep ocean's central discipline, that nothing is spent on what can be removed. The darkness of the Midnight Zone is not uniform. Even at depths where no sunlight reaches, the Midnight Zone is not evenly dark. Bioluminescence from thousands of organisms, flashing, pulsing, glowing in slow rhythms, creates a scattered, shifting field of cold light that a camera can detect at distances of 20 meters or more. The effect, captured on film, resembles a quiet city seen from altitude on a clear night. Not bright, not continuous, but present and alive in its distribution. The flashes do not illuminate. They identify, signal, lure, and warn. Darkness in the Midnight Zone is not the absence of light. It is the presence of a different kind of light entirely, produced not by a star, but by the animals themselves. Some of the oldest living animals on Earth are in the deep ocean right now. The ocean quahog clam, found along the continental margins at the edge of the midnight zone, has individuals confirmed to exceed 500 years of age. The Greenland shark, which descends into deep water and moves through the midnight zone on slow circuits, reaches maturity at roughly 150 years and may live to 400 or beyond. Glass sponges in the deep Pacific have been dated to over 9,000 years. Older than any standing tree, older than the first permanent settlements. These animals were alive before the printing press, before the compass, before the wheel. They are still alive now, in the cold and the dark, doing exactly what they have always done. The midnight zone will still be here long after everything above it has changed. The deep ocean changes slowly. Temperature, pressure, chemistry, darkness. These have remained within a narrow range for hundreds of millions of years, through ice ages, through asteroid impacts, through every mass extinction that reshaped the surface world. Species from above have come and gone. Continents have moved. The atmosphere has been transformed more than once, but the midnight zone, cold, pressurized, lightless, still, has maintained its character with a patience that belongs to geological rather than biological time. What lives there now lives in one of the most stable environments on Earth. The deep ocean does not rush. It waits and continues and keeps its own long record of everything that has passed above it. And so we come to the end of our time in the midnight zone. That vast, quiet layer of the world where the water has not seen sunlight in centuries, where creatures carry their own glow, where mountains stand unseen and clams outlive civilizations. Over these 5 journeys, we have traveled from the first edge of the dark at 1,000 meters down to the very deepest trenches, where sea cucumbers move slowly across floors that no light has ever reached. We have met fish who carry their own lanterns, animals who shed their limbs to escape, and sponges older than every story we know how to tell. The midnight zone is not empty. It is full of patience, full of strange light, full of life that has found its own way to belong in the dark. And you are part of this story too. The water in your body has cycled through the deep ocean. The oxygen you are breathing now was produced in part by the ocean's surface layer, carried on currents that began their journey in the midnight zone centuries ago. The deep is not separate from you. It has always been part of what you are. So now, let your breath slow. Let your shoulders settle. Let the thoughts from today grow lighter and drift, the way marine snow drifts. Unhurried, patient, taking all the time it needs to reach the bottom. The ocean is quiet tonight. So is the world outside your window. You have done enough for today. There is nothing left to carry. Good night.